Welcome back to my channel. Hope you people are doing well. Today in this part we are going to learn about the forces acting at a distance, that are field forces. Here we have three types of field forces. Those are magnetic force, electrostatic force and gravitational force. We are going to learn this about these forces in deep with the help of the activity, and we are going to know that why we call particular these forces only as our field forces. If you want to know what is field force and about that, how many types of forces we have and what exactly the force means, then you have to check my previous video, that is part 1 of this chapter. The link I have given in the description box. If you haven't watched that video, please go and check that video. Okay, it will help you to understand. So now I am going to teach you about these three forces. First, I'll take you through this magnetic force. I hope you people remember very well about magnetic force, because already you have learned about magnetic force in your previous classes. So let us recall about magnetic force. Okay. So here see, it is magnetic force. Like poles repel or push each other away, and unlike poles attract or pull each other. This action of pull or push arises due to magnetic force. A magnet can attract or repel another magnet without contact. So magnetic force is what? Field force, right? See here, like poles. Like poles, for example, we take as south and south pole. See, if we place uh, these two like poles to each other, facing each other, then obviously it will repel. Always like poles will repel, whether it may be south south, north north, whatever it may be, same poles, like poles will always repel. They will push each other away. Okay. And unlike poles always attract, or we can call in simple words that it always pull each other. And these action of pull or push, whatever it may be, pull or push arises due to what? Magnetic force. So see here, you can observe that there is no direct physical contact between these two magnets. If you simply place these magnets on the ground also, they will repel or attract. Okay. So this action will take place due to magnetic force. Hence, there is no physical contact between uh, these magnets. So we will call magnetic force as a field force. Okay. So let us understand this why we call this magnetic force as the field forces with the help of the activity, which you have in your textbook only. Okay. So you people also can do this activity at your place. Okay. So here we are observing the magnetic force. Okay. So now take a sieving needle and rub it with a bar magnet. Take a needle and rub it with a bar magnet several times. But always remember, you have to move the magnet in the same direction. Okay. So see. So now this needle, what will it will act like a magnet. This needle will act like a magnet. So now with the help of a magnetic compass, you can identify the north and south pole of these needles, because needle we have two corners, right? So let us take a red colored cork ball and put it on the south pole, and a white colored ball on the north pole. Okay. Now then drop it in a bowl of water. It floats. What? It won't sink, it floats. Okay. So with the another needle, you have to do the same thing. You have to rub uh, the needle with the help of a bar magnet in the same direction, and which the you have to place red and white balls to the south and north pole, right? So these two needles, see here we can see these two needles are floating in the water. So now make a such condition that two like poles, whether it may be red colored ball or white colored ball, they should face each other. See, as we learned earlier, like poles will always what? It will repel. It will push each other away. So here also, if we place two like colored balls, two like poles which are facing each other, it always push each other away. It will repel, right? If in the same way, let us see by placing two different poles, unlike poles, like red and white balls facing each other. So here you can see that it always attract, right? The magnetic force pulls what? Pulls each other. So see, hence it is clear that there is no physical contact between these two needles, right? So here we can observe that magnetic force is responsible to take this action. Okay, so we can clearly say that magnetic force is a field force. Okay, next we will learn about electrostatic force. So let us go through the definition of electrostatic force. The force exerted by a charged body on another charged body is known as electrostatic force. See, it is what it is saying, that it is exerting the charged body on another charged body. This force which exerts on each other, so it is known as electrostatic force. So let us take the activity to understand this. Okay, now let us observe what is electrostatic force. So now see, as we see in the diagram, we have a bits of paper and a balloon. Now take a balloon, inflate it and tie up the open end. Okay, inflate it and tie up the open end. Now cut a paper into small pieces. As we can see here in the diagram, you have to cut the paper into a very small pieces and place them on the floor. Okay, now rub the balloon with a paper. Now see, with the help of a paper, rub the balloon and bring the balloon near the pieces of paper. So first you have to rub the balloon with the help of the paper and bring the balloon near the pieces of paper. What happens now? What happens? What happens? It will what? It will attract. Are the bits of paper pull towards the balloon? Yes, obviously it will pull. Why does the balloon pull or attract the pieces of paper? So let us try to understand. Use pepper and salt in the place of pieces of paper. What do you observe? We can say that when the balloon is rubbed with the paper, it acquires an electrostatic charge. Right? It acquires what it acquires. It will acquire electrostatic charge on its surface. The balloon is now said to be a charged body. When it is brought near the bits of paper, the pieces acquire opposite charge and will rise and cling to the balloon. So now see, this balloon is a charged body. Now if you bring this balloon to the bits of paper, it will acquire what? It will acquire opposite charge. Okay, whatever charge the balloon has, the quite opposite charge the papers will have. So it will attract to each other. This force comes into play even when the bodies are not in contact. See here, the balloons and the papers, there is no direct physical contact between these two things. So it is the example of force at a distance or field forces. Okay, so now let us understand what is gravitational force. Here we have the definition of gravitational force. If an object is thrown upwards, if we throw any object upwards, will it go up in the sky? No, obviously it will fall down, right? There exists a force which pulls it downwards. So we have a force which pulls each and every object to downwards. Because of this, it falls down. So what is that force? That is what the force is, gravitational force. Let us understand more about this gravitational force. See, every object on the earth or close to the earth will experience this gravitational pull. Yeah, if we don't have this gravitational force, then Imagine if you don't have gravitational force on the earth, will I or you, will we be able to walk properly? No, right? The force of gravity is not just due to attraction of the earth, it is force of attraction exists between two bodies. It is not just due to attraction of the earth, it is a force of attraction that exists between two objects, okay, or masses everywhere in the universe. As the earth is so massive and huge, all the other objects close to the earth are attracted or pulled towards it. When you sit in your classroom, there may be a gravitational force between you and your teacher, and similar force exists between you and blackboard also. Okay, so there is a gravitational, we have a gravitational force uh, everywhere in the on the earth. You cannot experience gravitational force that exists between you and your teacher because it is very small when compared to the gravitational force exerted by the earth. Here you can, the gravitational force between you and your teacher is very small, so because of that you will never experience. But the gravitational force exerted by the earth is uh, very high when compared to these gravitational forces, and you will be understanding about this gravitation in your higher classes. So see, because we don't have any physical contact between these falling fruits, the fruits are falling from the trees and there is no direct physical contact between these fruits and the ground, right? So this is an example of field forces. Okay, so now let us understand this with one more activity explaining of field of forces at a distance. Concept of field: the force which acts between two bodies when the bodies are not directly touching it towards each other is called force at a distance. What we are learning from the beginning, the same thing, it is saying that there is no physical contact between two bodies. These type of forces are called as field forces or force at a distance. So here see, we are visualizing the magnetic effect here. Now see what we are doing, we are taking a bar magnet and place it on a table. Place a thick white paper over it. Okay, on a paper sprinkle fine powder iron. Now tap the table or a paper gently with a pen. What do you observe? Do you find any pattern? Obviously, see, if you place a bar magnet and a surrounding to that, if you sprinkle the fine powder of iron, obviously it will attract, right? So you can see that in a small space around the magnet, iron filings set themselves in a pattern because they are affected by this magnetic force. As I told you earlier, because of this magnetic force, they will get attracted. So they'll create some kind of pattern which we will see in our next slide. The pattern represents the magnetic field. The space around the magnet where it influences can be detected as magnetic field. This field is three-dimensional. See, this is the magnetic field. This is our iron magnetic bar, and these are the iron fine powder iron. See that the field in a region is in which a force can be experienced by another magnetic object placed at any point in that region. A body creates a field, and another body experiences the force placed in that field. See, here magnetic field surrounds a magnet and electric field surrounds electric charges and a gravitational field surrounds masses. So here see, let us understand this. Magnetic field surrounds what? Magnet, right? Because of magnet only we will get magnetic field, and because of electric charges we will get electric field, and because of cause and a gravitational field, what will do, it will surround masses. Masses means objects like you, me, fruits, whatever it be. The strength of a field in a particular region can be represented by field lines. The greater the density of lines, the stronger the force in that part of the field. Here see what they are saying, the strength of the field, the strength of any field, whether it may be magnetic, electric, or gravitational field, the strength will get represented in a particular region with the help of field lines. The greater the density of lines, the more the lines we have, so the forces will get the stronger the forces will be stronger. So in that part of the field, if you have any doubts, you can comment below. And in our next video, I'll be explaining you about the contact forces by taking some of the examples and including activity. Thank you for watching my video. Thanks a lot.